So, you want to make a black hole. Let's be honest. You probably just saw one and said to yourself, "Ooh, space thing with some glowing rings and a black center?" Well, in that case, this video is for you. What is a black hole? You have most likely seen one in movies or in other forms of media, but how can you actually get one? Here's this guy to explain.
Okay, black holes are celestial bodies whose gravity is so strong that even light, the fastest thing in the universe, cannot escape it. If you were to get close to a black hole, you would experience the process of spaghettification, in which your body would stretch so thin that your body would eventually become a line of atoms. Once you pass through the event horizon of a black hole, you cannot escape it. No one knows what's inside a black hole. No one will ever know due to the fact that once you go in one, you can't go back. However, a black hole is not a vacuum cleaner. If the sun were to be replaced by a black hole with equal mass, it would be as if the sun was always there, except we would freeze to them, of course. Due to this, objects can spiral around a black hole. The heat of this rotation forms an accretion disk, a disk that is extremely hot and bright, and forms around the black hole. If the accretion disk gets large enough and hot enough, the black hole is considered a quasar. If a black hole and another black hole go near each other, they'll spiral toward each other. This will take a long time, but as this happens, gravitational waves, ripples in the fabric of space-time, span out extremely far. A black hole collision is one of the most powerful collisions in the universe. Also, did you know that black holes can?
Yeah, that's great and all, but how do I make one? This isn't black hole fun facts. I want to make one.
So, you want to make a black hole? We need to get a new location, so the FBI won't know. Now, with a new location, we can actually start constructing a black hole. First, we need an object. Any object that is no larger than the human body will do. Second, we need to figure out the object's Schwarzschild radius. This is the radius at which the object will become a black hole, as long as the mass stays the same. We can figure this out by doing the following equation. Wait, that's not right. Oh yeah, it's the wrong equation. Here's the real one. Third, we need to compress the object to its Schwarzschild radius without changing its mass. We can do this by manipulating very strong gravitational fields to crush the object. Fourth, the object is now a black hole, but you probably can't see it. What gives gravity? Well, if your object is, say, the size of the human body, then the black hole is going to be 10 to the negative 23 centimeters long. That's smaller than the nucleus of an atom. It is also recommended to not go near the space, just in case. And that's it. You have created your very own black hole. But it is very small, and it's just a generic black hole. You want to make a spinning one? It's even larger? The size of a star? First, we need to talk about what a quasi-star is. You already know what a black hole is, but it's physically impossible for a black hole to be twice the size of the Milky Way in the span of 13 billion years. There simply isn't enough time for this to happen. Physics and astrophysicists have been trying to find out how these black holes got so big. Quasi-stars are the answer to that. A quasi-star is a star that may have existed back then when the universe was still very young. It's a black hole surrounded by tons of gas and energy for it to feed on. The black hole cannot eat the star all at once though, making the star absolutely massive. Such a star will be many times larger than the largest star, Stephenson 218. Back to making a black hole. Fifth, we must time travel back to when the universe was very young, where quasi-stars might have existed. Sixth, we separate the star exterior from the core. And now, you finally have your very own massive spinning black hole. If you cannot separate the star, just use extremely strong gravitational fields to crush a galaxy. That's it. That wasn't that easy. Anyways, thank you for watching and listening to less than 4 minutes of teenagers explaining how to create a celestial object.
I'm still listening.